Good morning. Welcome to the second last lecture of this ongoing online course on sustainable architecture, where we have been discussing about whole building performance tool DesignBuilder. Till yesterday's lecture, we have discussed all related to how to simulate buildings using the tool, how to create building, how to modify them, how to modify the materials, how to modify the geometry, how to modify the different performance parameters which are going to go inside the modeling of the building. One thing, if you remember, which we had left while we were discussing about the daylight in building, which is a criteria for evaluation in different green building rating programs, is the daylighting in buildings. So, how much of the floor area is being daylit adequately? So, one is how much and the other one is adequately. So, we also did manual calculations, if you remember. So, we had all the tables, we had the rules, we had the equations which helped us calculate how much of the floor area will be assumed or will be considered as daylit if we calculate it manually. We also showed in that particular lecture two comparative pictures where one was the manual calculation and the other one was a digital calculation, which was using the whole building simulation tool. Now, these tools are also equipped to help us with the daylighting calculations digitally. Instead of doing them manually, we can do it here. Whole building simulation tools take some other tools. For example, DesignBuilder takes help of Radiance as a simulation tool for calculating daylight, which is what we will show how do we go about it in today's lecture. So, in today's lecture we are going to discuss about the daylighting calculations using whole building performance tool DesignBuilder. Let us switch to the DesignBuilder screen now. So, today we are going to look at the digital method of daylighting calculation for compliance to green building rating systems. So, as we have already seen that almost all the green building rating programs across the world, they place emphasis on allowing daylight to enter the building, and in different rating programs different criteria are there. So, for example, the LEED requires at least 75% of the habitated area to be daylit, and daylit also has a range of values. So, if we again look at the example from LEED, so we have the daylighting defined using daylight factor, sometimes it is also defined using illuminance, sometimes it is also defined using other terminology which we have seen as part of our lecture on daylight. Most commonly used one is the daylight factor. So, what we have to really do is calculate what is the daylight factor in a room which has windows all around. So, if you remember, we already did the manual calculation using the rules, where we calculated how much from the side of the window the light will be available, for how much depth does it penetrate inside the room, if there is a partition then what happens, and all of that. Today we are going to look at the digital way of calculating daylight availability in a building. So, we take the same example of as that of the building which we have been considering for calculations. Now, the changes that you have to make to the model, or not to the model but to the settings, is first of all we go to the activity, and in this we say include zone in Radiance daylighting calculations. The moment we do that, the model will be used for calculating daylighting using Radiance as the engine. So, that is what we need to do in the activity tab. And when we go to the construction tab and we select whatever wall we have selected. So, we have already selected this particular template. If we go to this template, we already have created different layers of this wall. So, this was the wall, copy of ECBC wall. So, what we need to do is we need to change the surface reflectance of all these, because when we are talking about daylighting, the color of the internal surfaces, the finish of the internal surfaces, the finish of external surfaces, external ground, roof, adjacent building, all of that will make a difference. So, what we would do here is we would go to each of these materials. So, suppose we have gypsum board inside, we can go to gypsum board and again edit its properties. So, for each material we also have the surface properties available, and if you look at this, this is the visible absorptance. So, 1 minus visible absorptance is the reflectance. So, if higher is the absorptance, it implies darker is the surface. If we have a lower absorptance, which means the reflectance is higher and the surface will be reflecting more of the light. So, depending upon the kind of surface we are going to use, and we can also select the roughness. So, whether the smoother surfaces will have higher reflectance, which implies that they reflect more light whatever is incident on them. So, here we are only talking about the visible properties of the material as far as its reflectance and absorptance are concerned, as far as its texture is concerned, and all of that will impart the property, the visible property to the material, and these materials will automatically be used here and their surface properties will be updated. So, we can make changes in the external surfaces as well as the internal surfaces, where the finishes are going to affect the daylighting inside the building. Once we have changed that, we can go to the openings and we can also change the glazing type. We can check the glazing type. Here we have already selected the glazing type when we were changing the type of glass, the glass specifications. Here we can check upon with the light transmission values, the VLT values. Now, if those VLT values would depend upon the type of glass which is being selected for the building, for the glass, for the fenestration. Here we can take these values directly from the specifications which we get from the glass, or if we have a requirement, we can keep changing these VLT values and see its impact on the daylight. Once we have done that, we are ready for simulating for daylight performance of this building. And so, here is a tab where we click, which is called daylighting tab, and once we do that, it will calculate the illuminance and the daylight factor map for this building. Here, while we are simulating, before that we also have to check these properties here, these values here. The simulation type could be for compliance with different rating programs. Here we are only taking as general. We can report it in a map type, or we can also report it in a grid type. The source could be user defined or building, block or zone. Here we keep it user defined for now, and the value source could be daylight factor or illuminance. We can look at both of them. Usually when it simulates, it will give us the range of values both in daylight factor as well as illuminance, and they are usually synonymous, not synonymous, but they have the same ranges. Higher is the illuminance, higher will be the daylight factor. If you checking with daylight factor, we can also set their low values and high values. So, as per the rating programs, the minimum values for daylight factor are usually defined. So, as per LEED, the daylight factor has been defined to be a minimum of 2. So, we set the lower value of daylight factor at 2, and we can fix the higher value, the upper value of the daylight factor as well. So, here again different rating programs have different requirements. So, sometimes the higher value is also specified, because a daylight factor much higher than a certain value may also result in glare. So, we want to control the daylight factor. Rest of the areas will be shown as the dark areas. We can also fix the working plane height, and we can set the tolerance, which we usually keep the same. And here we can also decide to show the values for daylight factor or illuminance on the map itself. Once we have selected these values, and once we have clicked on daylighting, we will get a map like this. This is for the entire building, taking into account all the zones. And if you can see these faint lines here, these black lines, these are the virtual partitions. So, if you remember, while we were creating this building, we had very clearly communicated that virtual partitions are actually non-existent. There are no physical partitions. We are just making these zones to differentiate between the peripheral zones with that of the core zone. So, if you look at it here, we can see that the areas, the zones which are shown in red, are actually having a daylight factor of close to 10. And as we come down, we have some areas in the corners where we get a daylight factor of 6 to 8, 7 to 8, and then a large area where we have a daylight factor of around 5 to 6, and then 2 to 3 here. And this area, which is shown in black, has a daylight factor of less than 2, which implies that this huge percentage of floor area will not receive sufficient daylight. So, there is a large percentage of this floor area which is going to remain inadequately lit. It will not have enough light inside. So, we have to, it very clearly tells us that we have to look at the design, look at the plan. And here we can very clearly see that the width of the floor plate is much larger than what is required to allow daylight penetrate all the way through. Also, another thing which we can see here is that the peripheral areas, the areas which are close to the windows, they are too bright. They have a very high daylight factor, and which, as per some of the green building rating programs, is not acceptable. So, what we need to look at is the design of the windows. Maybe instead of providing 60% WWR, we just have greater WWR towards the north and lesser on the sides, or maybe we have ventilators and vision glazing separately. So, the upper glazing, which is more for the lighting, will have clear glass, while the one for the vision glazing. So, instead of having a window like this where it is like a single window, we can actually have a different design of the window itself. So, we may actually customize the window, we can draw on the wall. So, we can totally design the window as per our requirement. We can remove the windows which are available customized. So, we just click on this and we delete. So, we go to the wall and we go to the openings, and instead of 60%, if we say 0%. So, only on this wall it will change it to 0%, and here we can now draw the windows. So, suppose I want to have a glazing on top, and then I want to have a glazing in between, and I can also change the specifications of these windows. So, if I go to openings, I can also change the fenestration type, and we can select a glass. I can select a glass for the topmost window. So, I can select the glass for this topmost window as a clear glass. So, instead of ECBC fenestration, I can just take it to be a simple clear glass, and I take it to be, say, single clear 6 mm. So, this implies that I have, if we look at the properties here of the glass, it has a light transmission value of 88%. And while if I go back and if I look at the other window, this window, I might want to have a glass which does not have a VLT as high as that. So, suppose I am taking a double glass and I take a double, if I take a double gray and I select the properties 6, 13, 6, and if I check the light transmission, it is around 66%, and I selected OK. We can go back and we can simulate it again. So, we simulate the building again for its daylighting, and we can see the changes that it brings along with it. This is what we can do if we want to check different options for the daylight calculations, and every time we can see whether more and more area is being adequately lit, daylit or not. We can also select, if we want to go for the compliance, we can go with either of these options, and it will automatically tell, it will generate a report in the format which is desired for LEED or BREEAM or Green Star, and tell us whether this particular building plan and the fenestration design complies with the criteria, compliance criteria given in these rating systems or not. And we can see the changes. So, this is very good to be used at a very initial stage of design, where we are still working on finalizing the design of fenestration. Which orientation should I provide fenestration on? So, if I know clearly the fundamentals that okay, north is the side where I want to provide with fenestration, but I was not very clear whether I have to provide for a clear glass or I can provide for a tinted glass or I should provide for a lowy glass. This is an interesting way to look at this. So, we will simultaneously be looking at the daylighting calculations and also the energy implications of that. So, if we compare the values which we had earlier, we would see that the values for the southern side they have become more uniform, and similar thing we can do if we want to change the fenestration design and the glazing specifications for all the windows in this particular building, and we can keep experimenting and comparing the different options that we have that we can possibly have through design as well as specifications. So, this is what we would do while we are doing daylighting simulations. We can work with the design of windows, we can work with the specifications, we can work with the shading devices, we can work with orientation of the windows, and literally all the parameters concerning the fenestration. So, this was all for today's lecture, and with this we have already completed almost everything about the whole building simulation and the various purposes for which whole building simulation is used in green building certification and for green building rating programs compliance. In the last lecture on whole building simulation, we would be looking at some easy options of generating the base case models and using them for compliance. Here, what I have been discussing so far was where you want to improve upon your design. So, besides the compliance, the tool, the whole building simulation tools helps us in designing better buildings. If we have already designed, if we have already completed the design of the building, these tools also help us in proving the compliance, which is what we will see in the last lecture of this course, which is on sustainable architecture, in tomorrow's lecture. Thank you for being with us today. See you again tomorrow. Bye-bye.